Hello everybody, welcome to looking at calculus. Today we will be looking at rates of change modeling type problems for calculus the first semester, and in terms of what types of in terms of what type of problems that we'll be looking at specifically the position, velocity, and acceleration type problems, and also some modeling problems that you will probably see on the AP tests. But we're going to look at it in a more in-depth way. So then that way it's you get a better exposure of it. So this is basically what we're going to be looking at. So let's go ahead and talk a little bit for right now, just to begin before we begin how to approach these type of problems. So first, looking at position, velocity, and acceleration, those three types of equations, you're going to be given an equation of one of them, and what you need to do is you need to derive the other two. So for example, if I give you the velocity equation, you would need to maybe derive what's the acceleration equation and what is the position equation. Now, in terms of how they are related, we can think of it as in terms of their units, because position, that is basically looking at distance. So here, if I were to write it out, position is usually denoted in terms of distance, some sort of distance. So maybe like say in terms of kilometers. Now, when it comes to velocity, in terms of its units, that's going to be velocity is always distance over time. So maybe in some cases, it'll be kilometers per seconds. And when you look at it that from that perspective, the way you can think of it is, oh, you're solving for the tangent, or you're solving for the slope of that function in terms of time. So that means that you're looking at its derivative. And finally, when you're looking at acceleration, for acceleration is kind of the same idea, except it's in terms of maybe something like, say, distance over time squared. So maybe like kilometers over second squared. And from that, we can conclude that the acceleration would then be the derivative of the velocity then. So the conclusion I'm trying to make is that if you have a function for position, so for position, let's go ahead and say that it is a function of time. So we'll call it P of t. Then the velocity, the instantaneous velocity, would then be P prime of t. And then also the acceleration is going to be its derivative, meaning the second derivative, P double prime of t. So in essence, if you know one equation, then you could possibly find out the other two then, because if you know how to solve for the derivative, or if you can know how to solve for the function where the derivative is going to be given to you then. So let's go ahead and look into that, and then afterwards we'll look into some of these econ type problems where you have the margin and profit too. Okay, so here we go. First, we have a ball that is thrown straight down from the top of a 220 feet building with an initial velocity of negative 22 feet per second. I want to know, first of all, what is the velocity at t is equal to 3? So what I gave on the side is that the gravity is supposed to be negative 32 feet per second squared. And the reason why I give that is we have to have something to begin all of this then. So let me go ahead and kind of like show you how this problem would actually start out. The gravity that I gave you right there, the negative 32 feet per second squared, that's going to be our acceleration, because the gravity in this case is acceleration. So one way to think of it is that A of t, right, is supposed to be equal to negative 32, and then if you want to write the units down, feet per second squared. Now, what I like to do is from the acceleration, I want to find out what's the velocity. And if you remember what I just said earlier, the acceleration is supposed to be the derivative of the velocity's function. So what that means is if you know what the derivative is, which is negative 32 in this case, the question then is what is its, I guess, quote unquote, antiderivative? What is the function that makes the derivative negative 32? Well, going by the power rule, going backwards, then it would be negative 32 multiplied by t. And there's a little bit more to this. This is the tricky part when you're going backwards with this quote-unquote antiderivative. There's a constant that you're supposed to add, because if you think about how this is going to work, if I take the derivative of v of t, right, you would get that negative 32 that you want. But the derivative of a constant is equal to 0, which technically falls in the same conclusion that I'm looking for then. So for the sake of that constant, we actually need to add it in there, and we need to figure out what that constant is. Okay, Now let's go ahead and see if we can solve for that constant. And according to the information that's given, we should actually be able to solve for it. Because if you look closely, it says now the initial velocity is supposed to be negative 22. So what that means is that the function v of 0, right, when time is equal to 0, because it's initial velocity, you're supposed to get negative 22 for the answer. So if I plug in 0 for t and negative 22 for v of 0, then you will get negative 22 is equal to negative 32 multiplied by 0 plus c. And right there, you can solve for what c is. C is going to be equal to negative 22. So then that means that's going to be our equation for the velocity. And again, this solves for the instantaneous velocity at a certain given time. So v of t, as of right now, is equal to negative 32 t and then minus 22. And since we are looking for the velocity at t is equal to 3 seconds, I would like to solve for what's v of 3. And v of 3 plugged into t, that will give us then, let's see, negative 32 multiplied by 3 minus 22, which is going to be equal to negative 118. And for the unit, for that sake, it's going to be in terms of feet per seconds, because if you're going up by 1 unit, if you're going from feet per second squared as your acceleration, time going backwards, you're going to lose the time unit, and so it becomes feet per second then. Okay, from there, let's see if we can solve for the rest of this. What is the velocity at the time after the ball has fell 108 feet from the top? So with what's given right here in terms of what we're trying to plug in, they're giving us a position to actually work with. Now this right here, that's where the 108 feet comes from. This is something you have to be very careful about because of the wording of this problem. The ball, it has dropped 108 feet, so that means the position that we're given, we'll go ahead and call that x of t for position, or p of t, whatever you want to call it. So x of t is the notation that's normally used, is equal to, it's not equal to 108, it's actually equal to 220 minus 108, because remember, you have dropped 108 feet, so the x of t is supposed to give you the position of that time. So plugging it in, we're supposed to actually have x of t is equal to 112. So just to reiterate this problem one more time, I want to find out what is the velocity of the ball when the position of the ball is at 112 feet then, because it has dropped 108 feet total. So let's go back to part A, and what we're going to do is we're going to take the v of t equation, and we're going to go ahead and solve for x of t, meaning the position equation. So once again, let's go ahead and rewrite it. V of t is equal to negative 32 t minus 22. And again, in order to solve for x of t, we have to think about the relationship. X of t, the derivative of it, is supposed to be equal to v of t because the position in terms of time, if I take its derivative, well, that gives me the instantaneous velocity. We've dealt with this quite a few times back in chapter 2 or at the very beginning of calculus. So the question then is, what function, if I take the derivative, is going to give me that negative 32t minus 22? Well, let's take it one piece at a time. The negative 22, the function that'll give you that as a derivative, would then be negative 22t, just like we did in part A. Now, just like in part A also, there's going to be a constant that I can add on to it, and we're going to call this constant C1 because we don't want to, get it mixed up with the C that we used previously. But nonetheless, you still have to add a constant. Now, as for the negative 32t, the question again is, what function, when I take its derivative, will give me negative 32t? And again, this is a power rule thing because we're looking at a polynomial. So one thing that comes to mind is t squared, because the derivative of t squared gives you 2t, but there's going to be an extra 2 that's produced. So in order to compensate for that, you're going to have negative 16 instead then. Because if you think about now, if I take the derivative of negative 16t squared, that will give you the 2t from the power rule, giving you the 2 times 16 negative, which will give you the negative 32. Okay, so that part is a little bit trickier because we're using the power rule in reverse. Well, there it is. That's going to be our position equation. And what I want to do now is I want to plug in x of t is equal to 112 to figure out what is the time. But before we can actually do that, we need to solve for C1 just like we did in the previous problem. And if you go back now to the very beginning, it says that the ball is thrown straight down from the top of the building, which is 220 feet. So that tells me that the initial position, x of 0, is equal to 220. When t is equal to 0, 220 is equal to x of 0. So we can take that in and plug it in. So let's see, we're going to get 220 is equal to negative 16 times 0 squared minus 22 times 0 plus C1. All of those terms of zeros canceled out, so that tells me that C1 is equal to 220. And you can kind of see what the conclusion is from part A and also part B. Note that the constant that you have to add, it's very likely that constant has to do with the initial amount, the initial velocity in this case, which is negative 22, and the initial position in this case, which is 220. So that's kind of like an indication that you're doing this correctly. That doesn't always happen, but it happens most of the times. Nonetheless, let's go ahead and put everything back. So as of right now, we have x of t is equal to negative 16t squared minus 22t and then plus 220. And remember what we said earlier? What I need to do is I need to plug in 112 in order to into this equation. And I want to find out then from there, what is the time that is going to give you the height of 112. And with that time, I'm going to then plug it into the velocity equation in the solve for it. So as of right now, we're going to have to take this quadratic and we're going to have to solve for it. Let's see if we can actually kind of clean this up a little bit. Let me move everything all into one side because this is a quadratic form equation then. So let's see, 16t squared plus 22t, and then we're going to subtract 220, and that's going to give you negative 108 is equal to 0. From there, we're going to use a quadratic formula to solve for this, or if you can factor it, you can go ahead and do that too. But just to save you a little bit of time, that's going to give you t is equal to 2 because, I'll save that, algebra 2 part for you. And now that we know what the time part is, we're going to have to take this and plug it back into our velocity equation then. So final item, so v of 2 is what I'm trying to solve for, which is negative 32 multiplied by 2 minus 22. And so it looks like our not initial velocity, but the velocity at t is equal to 2 seconds, because that's when you have a height of 112, is equal to negative 84, and that's going to be in terms of feet per second. Okay, so hopefully this part where I kind of like skipped a few steps with the quadratic formula, you can forgive me for that one, because I just want to make sure that you guys can do the calculus. The algebra, that's hopefully not a problem because you guys are up into this point, but just in case, if you need help, let me know then. Okay, all right, here's the last part, part C. What is the average velocity when from t is equal to 0 to t is equal to 2? There is a difference between part B and part C in terms of what I'm asking for. In part B, I'm asking for what is the instantaneous velocity, so that means that I need to solve for the derivative at t is equal to 2. But whereas if I'm asking for what is the average velocity, well, average means that you have an interval to work with. Hopefully you haven't forgotten the stuff that we did leading up into calculus, meaning like all the stuff that we did with the limits and all the stuff that we did with the average that we did back in chapter 1. So with the average velocity that I'm trying to solve for, what I'm solving for is the following then. I want to know what is x of 2 minus x of 0 all divided by 2 minus 0, because that right there is the average velocity, okay, from the interval of 0 to 2, right? You take the difference in time, you take the difference in distance divided by the difference in time. So that is kind of like basically saying how you find the slope, right? You're trying to find a secant basically. Well, now we're going to go ahead and plug in everything because we have all three of the equation. So x of t, x of 2, right? When we plug in s of 2, well, we solved for it earlier. I do believe that was supposed to be equal to 112 because we did it over here in part B. Minus x of 0, meaning the initial displacement, that is going to be equal to 220 because that was given to us. And again, if you don't have it, you can just go ahead and plug it into part B then. All divided by 2. So clean this up as much as we possibly can. So negative 108 divided by 2. So that's going to be equal to negative 54. And that is also going to be in terms of feet per second then. Okay. All right, so those are the type of problems that you'll be seeing, hopefully in the homework assignment, or when you deal with this. And in the past, on AP tests, they used to give these problems for the free response, and unfortunately nowadays they are not going to be this simple. But as we get along, our calculus skills will get better, and we'll learn how to tackle those type of problems then. But it's here to stay. It's still basically the same idea. Acceleration, acceleration, velocity, and then position. And then they're all related to each other by derivatives. Okay, so let's look into something that's not physics, but maybe something that's like that's econ, but nonetheless is still calculus related. So here we go. This time I want to know the revenue to create X units of toys is defined by R of X is equal to that equation. And the cost to create the same toy is supposed to be C of X, which is supposed to be that equation. So we have two equations to work with. Let P of X be the profit of selling X units. Find P of 10 and explain what that means. So this is kind of like something that kind of helps you to get the ball rolling. So this is what we call scaffolding in math, because it's supposed to be kind of like an easy setup problem. So then that way you can understand how it works for the second piece and the third piece and so forth. So first off, P of X, that's supposed to be the profit of how much you're supposed to get for selling X units. Now, one equation that's given to us is R of X, which is the revenue. So that means that that's how much your money that you're supposed to be getting for selling these toys. But then there's also C of X, which tells me how much you're supposed to be spending in order to make these toys. So in terms of what the profit is, right, the profit is supposed to be equal to the revenue minus the cost, because when you sell something, you have to consider how much money that you're taking in order to create all of these things too. So it works out in any situations. If you're selling a lemonade, you have to take into consideration how much you bought all the sugar and also the lemon and all those stuff for before you figure out what's your total profit out of this. So what I need to do is I need to kind of replace this now with the equations that I have. So P of X, the equation that I'm looking for the profit, is supposed to be R of X. So that's negative 3x cubed and then plus 600x squared minus the cost equation, which is 357x squared and then plus 1800. And so when I take this and clean it up, that's my actual profit equation then. So let's do the math for this one. Negative 3x cubed and then 600x squared minus 357x squared. That's going to be positive 243x squared. And then that's going to be minus 1800. And that's going to be x then. So that's my total profit now. I want to solve for P of 10. So that means I'm going to plug 10 into this equation to see what I get then as a result. So P of 10 is going to be equal to negative 3 multiplied by 10 cubed. So that's going to be 1,000. And then plus 243 multiplied by 1,000. Not 1,000, 100 in this case, right? So because it's 100 squared, 10 squared. And then we have minus 1800 and then another 0 because we're going to multiply that 1800 by 10. Okay, so taking all of this and plug it into the calculator, let's see. So that's negative 3,000, and then plus 243,000, and then minus 18,000. So the result is that this is equal to 33,000. And in terms of the explanation, because I want to know what this number actually means, is that you are going to sell 10 units of whatever it is that you're making. And this 33,000, that's how much money that you're going to make by selling 10 units then. So in conclusion, you are going to make a profit of $33,000 for selling 10 units. Okay, all right. Let's now look into the next part, which says find P prime of 10 and explain what that means. Now, let's go ahead and first solve for this numerically, and then afterward we can go ahead and explain what that means then via the units then. So I'm going to go ahead and take my previous equation. So P of x is equal to negative 3x cubed and then plus 243x squared and then minus 1800x. So P prime of x, according to my power rule, that's going to be negative 9x squared and then plus 486x and then minus 1800. I'm now going to plug in 10 for x. So P prime of 10 is equal to negative 900 and then plus 4860 minus 1800 then. Okay. Trying to clean this up, the numerical value for this is supposed to be equal to 2160. Okay, now that's the math part. That's the easy one because we're just kind of grinding things out. But now let's go ahead and try to figure out what this means. The easiest way for me to explain this is let's think about the units for each one of these. P of x, the P of x right here, the unit is supposed to be the amount of money that you're supposed to get for the profit. So that was from part A. Now for P prime, if I take the derivative, remember the derivative is supposed to represent the instantaneous rate of change. It's supposed to represent the slope. So meaning I need to look at the change of y divided by the change of x. Well, the change of y over the change of x, that means it's going to be the dollars because that's the change of y, divided by the change of x. In this case, x is supposed to be the number of units then. So then that is supposed to be our answer. So the conclusion is that this P prime of 10 that we're solving for, that represents how much more profit we're making from selling from the 10th unit to the 11th unit then. So meaning if I'm going to go from selling 10 units, which is supposed to be $3,300, if I sell 11 units then, instead of 10 units, meaning 1 unit more, I'm going to make about approximately $2,160 more then. So here, let me just kind of write this out. P prime of 10 is equal to the amount of profit change from selling 10 units to the 11th unit. Okay, so by selling one more unit, the 10th unit, actually, let's kind of clean that up a little bit. Okay, so from selling the 10th unit to the 11th unit, you're going to make approximately $2,600 more then. Okay, so which in this case, let me just kind of write that down, $2,160 then. Okay, all right, now let's look at the last part right here. I want to know how many units must you sell to obtain the maximum profit. Okay, I want to know how much money, how many units must you sell in order to make a maximum profit. To give you something to kind of work with, because we're actually kind of looking ahead right now, this type of problem, part C, you won't actually encounter it until maybe like say the next chapter because it'll be more defined. But for right now, we can kind of get an idea as to what I'm looking for. If you're trying to look for the maximum, right, of a function, because that's what I'm looking for in this case, let's go ahead and draw kind of like a quick sketch. So here is a graph of where you have a curve. And you'll note that the maximum, right, and this always happens if your equation is going to be some sort of polynomial or something where the curve is going to be smooth. So let's just say that your curve is going to be P of x right here, and your maximum in this case, and I know it's going to be a smooth curve because P of x is a polynomial in this case. If you look at where the maximum is located, right, so here, the maximum, you'll notice that the slope is equal to 0. The instantaneous slope is equal to 0. And that's actually similar for over here for the minimum too. In case of the minimum, the slope here is supposed to be equal to 0. Those are what we call local maximum and local minimum. So the conclusion is I want to find out where those maximum and local minimums are because I want to know, well, where is it that you're making the most money? So let's go ahead and now translate that into this calculus that we're doing. I'm looking for the instantaneous moment when your slope or your tangent is equal to 0. So what that means is I need to solve for the derivative and I need to set it equal to 0 and solve for that value of x. Now, if you're wondering, okay, well, that allows us to solve for the maximum or will that allow us to solve for the minimum? Well, we can just go ahead and plug it back into the original equation to figure out which one is which then. So let's go ahead and run through the procedure so you can see what I'm talking about first. So first, we're going to go ahead and take our derivative equation from part B because we're going to need that for this case. So rewriting from part B, p prime of x is supposed to be equal to negative 9x squared and then plus 486x and then minus 1800. And remember, all of that is going to be set equal to 0 because I want to look for those local maximum or local minimum where the tangent is equal to 0. Okay, this is not too bad because this is a quadratic and we can solve for this quadratic. Now, unlike the one before, I think we can kind of clean this up a little bit because I noticed that everything is divisible by negative 9. That makes it a lot nicer. So we're going to divide by negative 9 from both sides, and I can do that because the other side is equal to 0. So we get x squared minus 54x and then plus 200 is equal to 0. And lo and behold, we can factor this into something nice. That's x minus 50 multiplied by x minus 4 is equal to 0. So that tells me x is equal to 4 or x is equal to 50. So these are what is known as the critical values. And when I say critical values, that means those are the values of x which will allow me to either get a maximum or a minimum. So in order to determine, well, which one's the maximum, which one's the minimum, I'm going to go ahead and plug it back into the original equation, p of x, and then figure it out. So final step is I'm going to have to solve for p of 4, and I'm going to solve for p of 50, and let's see which one gives me the largest value because I'm looking for the largest possible maximum. So if I solve for p of 4 just to save a little bit of time because this is just plugging into the calculator. And remember, p of x is the original equation that we had over here, the profit equation. So that's going to be this guy over here or this guy over here. So p of 4, that is going to be equal to negative 3504. So what that means is if you sell 4 units, you're actually going to be losing money because in the end, it looks like your cost is going to overtake your revenue, giving you a negative profit in this case. So that's probably not what I want to look for. Whereas p of 50, if I plug 50 into the equation of p of x, you're going to get 142,500. So I think right there, that's going to be our local maximum then. And that's going to be the answer that we're looking for because at 50 units, you're going to make a profit of $142,500 then. So that right there is going to be our answer. All right, so as I said, I think the problems that you probably will run into in your textbook will not be as in-depth as this, but if it is, great. But if it isn't, then hopefully you get an idea as to what is it that that they're looking for. A lot of the times, what most likely will happen is they're just going to ask you to take the equation that they give you and solve for its derivative and plug in the values of x or t that they give you. Okay, so hopefully this helps out. I will see you next time and have a good one. Goodbye.